Hey, what's up YouTube? At least I think that's what you're meant to say at the beginning of a YouTube video. This video is about how the Romans got so very close to discovering the force of gravity about 1600 years before Sir Isaac Newton. They got so close, but there was just one final step they missed out on. They had all the information they needed, but they lacked that last leap of genius. I'm making this video because if you see something about the ancient Romans on YouTube or television, you can be quite sure it goes like, this is what a Roman soldier looked like. They marched along straight roads, they ate fish sauce, and at night they went home and had an orgy, or something like that. That information probably comes from 2 or 3 pages of a single Roman book. There are dozens, maybe hundreds of books that have come down to us across the millennia, so we're going to see what the Romans are really like for the first time in the history of the world, certainly the history of YouTube. I'm going to do it in 2 ways. First of all, I'm going to show you how scientific they were and how open-minded they were to new ideas. And then we'll look at gravity in particular, which will include the moon, which is why I'm videoing the moon now. These days, most people realise that the sun is in the middle of the solar system and the Earth and the other planets go around the outside. The first person to point this out was an ancient Greek called Aristarchus in 320 BCE. I'm going to read something from Seneca. He was Emperor Nero's right-hand man, and he's wondering about, is it the sun or the Earth that's in the centre of the solar system? It will be relevant to investigate these matters so that we may know whether the universe travels around while the Earth stands still, or whether the Earth turns while the universe stands still. And you might think, well, this is an innocent enough question. If he'd have asked that question in the 16th century, like Bruno, who was a monk in 1600, asked the question, or actually Bruno said the sun is in the centre of the solar system, following Copernicus' work in 1543. Bruno was burnt alive for saying the sun was in the middle of the solar system. Nobody set fire to Seneca though, because of this reason. This is what Cicero wrote in the 1st century BCE. Let us imagine someone of the highest qualities. In the first place, they must be of outstanding intelligence, for virtue is not easily found in sluggish minds. Secondly, have an eager enthusiasm in the quest of truth, one centred in the knowledge of the universe and the disentanglement of the secrets of nature. So, when Seneca was asking us questions about is it the Earth or the Sun in the middle of the solar system, he was acting to the highest standards of what Romans thought were important. You know, he wanted to have a knowledge of the universe and to disentangle the secrets of nature. "1-0 to the Romans, and when I say the Romans, really I mean the sum total of civilization from the Babylonians, Egyptians, the Greeks and the Romans. After the Romans, civilization took a bit of a dip, and for 1,000 years science and things like that were discouraged. In fact, for a 300-year period, the only people who could read and write were in the church, so we nearly lost all that vital information. Back to the force of gravity. Sir Isaac Newton discovered it in 1687. He did so through 3 simple steps. First of all, he said an object at rest will remain at rest unless a force acts upon it, which seems quite straightforward, but it's an important first step. Then he said, when he saw an apple fall off a tree, it was a force of gravity that attracted it to the earth, and the gravity pulled it off the tree and it made it land on the earth. It didn't go flying off sideways. The apple was at rest, so a force must have acted upon it. Then the third step is his great leap of genius, and he's the first person to realise this after the millennia, after the Babylonians, the Egyptians, the Greeks and the Romans. He's the first person to realise if the earth has a force of gravity, as he called it, which pulls apples towards it, maybe the same force holds the moon in orbit around the earth. And if earth has gravity, maybe the moon as a great heavy mass has gravity, and it's that force of gravity from the moon that affects the tides. Okay, so those 3 steps. Now, how close did the Romans get to it? Or how close did the ancients get to it? Well, in the 4th century BCE, Aristotle wrote, "There is no effect or motion on an object without a cause." Well, that's pretty much what Isaac Newton said, wasn't it? Almost word for word. Then things get a bit more tricky. This is what Cicero wrote again in the 1st century BCE. The force of gravity makes all things tend to the world's centre, which is also the lowest in what is a sphere. Well, that sounds pretty good, doesn't it? The force of gravity. But if you read the original Latin that Cicero wrote, it gets a bit more problematic. Ca omnia delata gravitate media mundi locum semper expertant, qui est idem infamus in rotando. Can you see what the problem is? Now, my Latin, as you can tell, is bloody awful, but Google Translate has come out of a much more literal, direct translation, by which all things had been informed of the gravity of the centre of the universe will always look for it, which is the same as the lowest in the case of a sphere. Can you see the thing? Something's been informed of the gravity, the force, or the great heavy weight, as the proper Latin should be, will always look for it. Aristotle, our friend Aristotle, wrote that things stay on planet Earth because there's something within them that wants them to get through to the centre of the Earth. So, for example, I don't go flying off into space because I'm a great heavy weight, and there's something within me that wants to get through to the centre of the Earth. Also, Aristotle went on to say light things travel up towards the moon. Well, light things, smoke, ducks, things like that, I don't know. That's not really seen as an outside force. But now we come to Pliny, who was writing between about 70 and 77 AD. He died when Mount Vesuvius erupted, which covered over Pompeii in 79 CE. He's working in a library and he's doing his research because he's writing an encyclopedia. Okay, so he's being quite thorough and trying to be scientific about it. He says, and he's talking about what ordinary people think about gravity, why things don't go flying off the Earth. The theory being that humans are distributed all around the Earth and stand with their feet pointing towards each other. Ordinary people inquire why the person on the opposite side doesn't fall off. That's a good question, isn't it? But then he goes on to say, gets a bit more useful. Isaac Newton was thinking about apples. Pliny is thinking about water. But what the crowd most debates is if it must believe that the conformation of the waters also rises in a curve. So if normally you see a pond, water's lovely and flat, but the Earth's a globe, oceans go over a great span of the globe. Why don't they fall off the edge? Why the land is not visible from the deck of a ship when it's in sight from the masthead? So you're on a ship, you can't quite see the shore, but if you go up to the top of the mast, you can just see a bit further over the curve of the Earth. And why, as a vessel passes into the distance, if some shining object is tied to the top of the mast, it appears slowly to sink, and finally it is hidden from sight. So I'm standing on the shore, I can see a ship just disappearing over the horizon. The very question as to how, although the sea is globular in shape, its edge does not fall away. So the Earth is a sphere, the oceans go around it, why don't they fall off the side? Which is a good question. Hang on, I just sorted out the camera. But then he comes up with the answer. He says, for they argue, while it is the case that water travels downward from an elevation, it is manifest beyond doubt that the lower an object is, the nearer it is to the centre of the Earth. It therefore follows that all the water from every direction converges towards the centre, this pressure inward being the cause of it not falling off. So he doesn't actually say it's an outside force, but he does say, the water's being pressed towards the centre of the Earth. That's quite close, isn't it? You can argue it either way. Did he see it as an outside force? Did he just think that there was something in the water that made it want to go towards the Earth? But it doesn't matter because we don't get to that last important step. He doesn't realise that the moon is held in orbit around the Earth by the force of gravity, the same force that causes the water to come towards the Earth. And he doesn't realise even that the moon is affecting the tides by the force of gravity, although he almost does. I'll read out what he says so you can see. Moreover, the lunar difference is manifold. To begin with, its period is 7 days, inasmuch as the tides, which are moderate from new moon to half moon, therefore rise higher and at full moon are at their maximum. And he goes on to say, when the sun and the moon are lined up, the gravity or the effect it has on the tides is even stronger. And in fact, the first person to point out that the moon affected the tides was someone called Pytheas, who travelled to Britain in 325 BCE, which must be one of the earliest people to visit Britain and to write about it, rather than just writing about it from a great distance, which is probably the best way to write about Britain. So he knows there the tides are affected by the moon, but he doesn't realise it's the same force that holds us onto Earth, holds the water onto the Earth, is the same force that attracts the water towards the moon. It's so annoying, isn't it? They got so close. And to add insult to injury, our friend Aristarchus, who thought the sun was in the middle of the solar system, in 230 BCE, wrote, "The Earth is like a point and the centre relative to the sphere in which the moon is moving." It's so annoying, they got so close, they didn't quite get there. And it's a shame, because it really would have helped their understanding of everything. You know, the ancient Romans thought, we've got planet Earth, we're all here. What goes on in the heavens is completely separate. If they'd have realised the same forces on Earth, gravity, was the same force that held the moon in orbit and affected the solar system, they would have realised, you know, the heavens weren't quite this distant, exotic place that they thought it was. Although, maybe you can be a bit hard on the ancients, because making this video, I discovered lots of things about the moon, which I'd never, in 52 years of being in this world, I hadn't realised. So, for example, we all know about the different phases of the moon, you know, full moon, half moon, crescent moon, new moon, all these sorts of things. I didn't realise until I had to get an app to work this out. The moon rises above the horizon each day at a different time, moonrise, and it sets, it goes below the horizon at a different time every day. Some days it doesn't even come up above the horizon. So I think either you need an app on your phone or you need Stonehenge. Thank you for watching. Please remember to click the like button and subscribe, and leave a comment and all those other things you have to do on a proper YouTube channel. We shall now listen to some Clair de Lune to relax. Next video, how close do the ancient Romans get to discovering the Higgs boson particle?